Okay, so we hit the max recording length. I had to start another video here. So all I did was just pre-tin this spot, and we're gonna go ahead and do what I should have done first off, which is show you the location for feeding that one to the other side. So this one's a little easier to see. The top side, there's a through hole right here, right near this X clamp. It's not underneath it at all. It might look like it in the video though. And that's where I'm going to route the post out, and then it'll go up and over to the actual post location from there to there. So I'm going to grab my captain, or I don't really know. I've never heard anybody else pronounce it. It's spelled K-A-P-T-O-N, Kapton. So we'll go ahead and use the same method. Use the tweezers to get down low so that we don't bend the wire, and just kind of gently feed some through here. Kind of a repetitious motion there. And then when we flip it over, we can see where it's come out right there, and we can pull some length out. And again, this is our CPU RS, or excuse me, our post, which is letter C on the board. So just go ahead and strip and get some end there visible, and we'll put that into letter C. And then same place with the wire routing. A and C don't seem to affect each other in my experience, so we'll just give it a little tug on the length that's through there to recede that a little bit. And sometimes I pull too much and I need to redo it. So they're essentially overlapping. They're running over here, down, over, in, right? So we'll flip that back over. And now you can see where we're out here and we're over to the post location, so it'll just trim it with a little bit of excess. And now we'll actually route this bad boy under the X clamp so that it's nice and tight. Oh, come on, feed through there. Why are you fighting me? There we go. And then while it's still a little bit loose here, I'm going to go ahead and strip some. There we go. Strip the end so we got a nice end to work with, and feed that all the way through. Go ahead and get this position so we can place that. And I'll just use the tweezers to hold this. But again, same sort of thing. If you hold it with the tweezers and then you push it with your finger downward so it angles down towards the board, kind of works out nice, because then when you get down to the board, you just push down a little bit and it makes a nice solid contact. And be gentle, because you don't want to ruin that. That's a small little via and stuff again. And then here, because the center of that is right between the CPU and GPU, rather than some hot glue, which I just kind of feel like is going to melt right there. I mean, right in that middle, it's got to get balls hot, right? So I used a little bit of Kapton. I think I spelled that wrong. I think I told you this was Kapton wire. What is it called? Kynar wire. Ah, I'm totally mixing up my terms. This tape is called Kapton tape, K-A-P-T-O-N. The wire is called Kynar, K-Y-N-A-R wire. Apologies for the mix-up there. I'm a little tired. It's pushing 10 p.m. here, so, and I worked a full 10-hour day. So there we go. We've done C, and it's routed. D is routed. Everything is done that way. So we will go ahead and last step, I guess, that we need to do is attach D. So we just trimmed it off before, and we didn't actually solder it to the chip. So push the ground wire out of our way. Using my little snips, we'll trim off D with a little bit of excess. Generally, we'll route them all to it when I trim them, so I don't have leftover wire. But again, I'm going to blame the fact that I'm videoing. So take that off. Put D right in there. Go ahead and connect it up. And voila. So now you saw us wire power ground A, B, or A, C, and D. We have not yet done B. B is CPU RST. Now for a newbie, this little point that's right here, this is totally not advisable for a first timer. There's a really easy alternate that doesn't affect boot performance. It doesn't affect any of that sort of stuff. So let me demo that one to you instead of you guys trying to see how to do the regular point. So again, just to be clear, CPU RST, the regular point, point B is right here on this little head, and people will knock these resistors off, and that will cause the console not to boot. It's right near the, I believe that's the south bridge. So what we can do instead is this point right on the underside, FT2R2, right here, right next to this hole that goes right up. So what I'll do is I'll just grab a piece of wire, strip that back so it's not massive and we don't bridge anything. Put a little bit of solder flux on that bad boy. Let's see, are we on? Yeah, we're on. Okay. Grab some solder and we'll just tin up this spot here. And then we'll just take our wire. We got a tinned spot, tinned wire, and it should just touch to and stick, nice and sticky. That's a way easier point than trying to mess with that tiny little bunch of resistors and all that sort of stuff. And again, it doesn't affect boot performance, and it, has the same end result. So much easier of a point. I really wish Team Executor would have never even suggested that other point to all these users, because there are so many dead consoles out there because of that point right there. So I'm just pulling through. I went, instead of through the hole that's immediately next to it, I went over and through that hole. And then I'm just going to go ahead, since I already got it warmed up, I'm just going to throw a little bit of hot glue right here, just to make sure that thing doesn't get yanked and pulled loose. And I don't know if this is on camera, but I'm going to put a little bit over here by that post point as well, just for giggles, because I'm right here and I got the gun in my hand. So, glue gun, that is. Alright, so we'll turn this back over, and you can see the wire comes out there nice and clean looking. We'll just push it down, push it over, get a quick kind of measurement on where we need to be, trim some bare wire out of this. And this one I did not use Kynar wire. This is standard stranded wire or whatever. B is, I found, not to be sensitive to what type of wire or interference or anything like that. That's why I also say it doesn't affect boot times or anything. It's the standby click is the clock that it's taking. It seems to be more of a either present or not signal. Haven't found its wire routing or anything like that to really affect anything. So, all right, so we've done. We've wired the thing up. The console is in theory RGH to this point. So what we need to do is slide this bad boy back into its metallic case. Keep it nice and protected. We need to put the fan back in at minimum, because these things get hot super fast. So we need the fan in there, and then we need the fan shroud, because without this fan shroud, this nice plastic piece, all you're doing is blowing air around. With this in place, it can actually pull the air through across the heat sinks. So now what I'm going to do is go ahead and connect power, and what you can see here is that the switch is still in the PRG or program position. I'm going to route my HDMI right over here. Oh, my camera holder jigger, which is this giant floppy bastard. was in the way of my HDMI cord. So I'm going to get my HDMI plugged in. Power's plugged in. And then if I go ahead and flip the switch on this, see the light will come on. So we definitely have power there. And let me grab my ring of light board. We'll slide that into the front here. So now, in theory, because we've already written the ECC, we've already programmed the console, when we go ahead and power this bad boy on, we should get glitch cycles. And we are, so check that out. We got the nice glitch pulsing. So that's totally normal, the multiple rapid pulsing. And then actually we just got a successful boot. And here we have Zell on screen. So we just successfully RGH 1.2 to get Zell. That's going to give us our CPU key here in just a second. The way that I do it is I plug in my network cable, which will give me my IP address, so 1.227. So here in JRunner, I'll type in .227, hit enter, pulls my CPU key right through for me, so I can hit make sure that glitch 2 is selected. I'm going to create XE build. I'm going to power off the console while this is going on. So, because right now what we have written to the console is just the ECC, which just gives us Zell, which is the CPU key, which is what we need in order to get all of this information. So now we've actually built a NAND image, right? So let me go back to our mount here, see if we can make this bad boy do its thing. Come on. I guess the computer screen can move easier than the phone can at this point, or the camera. Come on. Maybe I'll do some editing on this. Alright, so we've got the We've got the JRunner built a new NAND image. So what I'm doing now is I'm just, that NAND header that we left soldered in before, I'm just grabbing that wire. I'm going to plug it into my NANDX. I'm going to leave the power connected, plugged in, but not powered on the console. And I'm just going to hit my right NAND button. And you can see here that I'm writing the updflash.bin to the console. So you can see my progress bar coming across. We'll pick up when that's next to done. Alright, so picking back up here, you can see that we're about to finish the write here. So when we get to 3FF, that will be our indication that we're completely done with the writing of the new NAND file, which we did via the NANDX and JRunner, obviously. So that just completed. And I'll just show you how we physically do this. So the NANDX is plugged in to that same header we soldered in at the beginning of the video. So if we go ahead and unplug that, we can just quick disconnect the power for just a moment. Just give it a quick 5 count or whatever, and then plug it back in. So now we've actually written a full updflash.bin. So when I go to power on the console, we should get glitch lights, and then a boot, and you can see the full boot into the dashboard. And now the console's RGH running a full RGH NAND, RGH 1.2, and on video in just over, what, 35 minutes or something? And that's with all my yakking and stuff that I'm normally not doing. So that was an instant boot with a Rev C in a current dashboard Jasper. And let's just do another one just for funsies. So we can watch the glitch light here and see it pulsing on and off. That multiple flashing, that's kind of like one cycle. And then so there would be 2, 3. So we just had a 3-cycle boot. Still, so much better than RGH2 historically would be. We just had an instant boot and then a 3-cycle, And that was just booting it back to back, basically. We'll do one last one here. I'm going to show you just because I'm super pleased with how these turn out. I'm going to use my little screwdriver here. I'm going to press this eject button because the eject button's not actually in the console. So when we press this, so we just ejected, and so that's what, 1 or 2 maybe. So by turning it on with the eject button, we're going to boot into Zell. So that's, I think that's 3 to Zell as well. So that's still under like 15 seconds. Booting both the dash and Zell every time. So that is how you can RGH 1.2 a Jasper on current dash as of today 17349, and have it basically instant booting with a Rev C. Thanks for watching, guys. I hope you enjoyed it.